All right, guys, let's look at our second case. This is going to be a perfect square trinomial that we're going to be factoring today, which again, hopefully sounds familiar. We talked about this when we learned how to multiply binomials, right, in the special cases. Let's go right into our very first example here. So I'm going to show you how to do this in two ways as well. The first method that we learned was creating a Punnett square, where we wrote it as 3x plus 2, 3x plus 2, and then from here we would carefully multiply it out. 9x squared, 6x, 6x, and 4. From here, we would combine these like terms. What we get here is we get 9x squared plus, now you notice I have two 6x's, so I'm just going to write that like this for now, plus 4. And then if I simplify this, I get 9x squared plus 12x plus 4, and this is my final answer. We also learned how to FOIL, which I'm not going to really go into here. So let me show you another way you can do this. First off, I know that this is a perfect square trinomial because I'm multiplying a binomial to itself, right? You see the same binomial twice, which by the way, you can also write it as a quantity of 3x plus 2 squared. And so if you remember the structure, what we talked about last time was, hey, if I were to multiply this out, I know that the first term will just be the first term in the binomial squared. I know that the last term will be the last term of the binomial squared. I know I'm going to put a plus sign here simply because there's a plus sign in that binomial expression. I'm going to put a 2 here because if you remember, there's two of the same, right? There's two 6x's. And then I'm going to put 3x because that was my first term. And then I'm going to put a 2 again only because that's that term there. And then from there, we would just multiply this out. 3x times 3x is 9x squared, plus 2 times 3x is 6x. 6x times 2 is 12x, plus 4. And if you notice, we got the same answer. So what we're going to be doing when we're factoring is we're going to be taking advantage of the structure. But the thing that gets kind of tricky is, when do you know this is a perfect square trinomial? So we're going to look at a couple of examples of things to look for to determine whether something is a perfect square or not. Let's look at number 1. I'm going to do this in two ways. The first method is the X box method. So you're creating an X box. I know the first box is x squared. The last box is 25. I know that my product is going to be 25. And my sum is going to be 10. What two numbers multiply to 25 and add up to 10? It would be 5 and 5. We would put 5x here and 5x here. And then from there, we're going to pick any row or column. Doesn't matter because they're the same. I'm going to pick the first row. Ask myself, what's the greatest common factor of x squared and 5x? That's x. And then from here, you would just carefully fill out this Punnett square. And so my final answer would just be x plus 5 times x plus 5, which we can simply write it as x plus 5 quantity squared. And that's my final answer. Now, this is one way you can do it, right? You can always factor using a Punnett square, right? The X box method. Let me show you how I could use the structure to factor this much quicker. Now, the thing is, you have to check if this is a perfect square trinomial or not. And there's really a couple things you need to check for. First off, is this first term a perfect square? Can you write it as something squared? The answer is yes. X squared is simply x to the power of 2. Then you want to check if the last term also follows that same structure. Can I write 25 as something squared? Again, yes you can, 5 squared. Now the tricky part is checking this middle part. Can you write 10x as 2 times the first term times the second term? When I say the first term, I mean like the first term being x and the second term being 5, right? Can you write 10x as 2 times x times 5? If you can, then you know that this is a perfect square trinomial. Which means when you write down your final answer, I know it's going to be something of this form. I'm going to put a plus sign here simply because there's a plus sign here for the middle coefficient. And so the first term will be x because of the fact that it's x as being squared. I know my second term in the binomial is going to be 5 because it is 5 that's being squared. And this is my final answer. Again, you get the same answer as we did earlier. But we're going to be taking advantage of the structure to factor a perfect square trinomial. So looking at number 2, we'll do this one together as well. You want to check a couple things. Let me actually rewrite this right here. So first thing you want to check is, can you write 9x squared as something squared? The answer is yes. You can write it as the quantity of 3x squared. That should be a plus. Can you write 16 as something squared? And the answer is yes. You can write it as 4 squared. Now the thing you need to watch out for now is this 24x. Can you write the 24x as 2 times 3x times 4? And the answer is yes. They are the exact same. And this is a minus, this is a plus. And so what this tells me is that because it follows the structure, I know that I'm going to get a perfect square trinomial. First off, I'm going to put a minus sign here simply because there's a minus sign here, right? I know that this 3x here is going to be my first term of my binomial. And then I know that this last term being squared, that 4 will be the second term of my binomial. And this is my final answer. This is a lot faster than using the Xbox method, because if you use the Xbox method, you'd have to multiply 9 times 16, which is such a big number, and it would take a while to figure out this Xbox method, right? So you always want to look for the structure, but keep in mind, just because it's a trinomial doesn't mean it's always going to be a perfect square trinomial. Sometimes you will have to use the Xbox method, especially if this middle term here doesn't work out, right? So keep that in mind, okay? At this time, I want you to try number 3 on your own, follow the same structure, and see how you do. So this first term here, I can write this as 2x quantity squared. This last term here, I can write it as 5 squared. Let's make sure I can get 20x, writing it as 2 times the first term times the second term. If you notice, I can. So let me put a minus sign and a plus sign here. And so because this follows that structure of a perfect square trinomial, I know that my final answer is going to be of this form. I want to make sure I put a minus sign here because there's a minus sign here, right? I know that I'm going to put a 2x here because that's the first term. I'm going to put a 5 here because that's my second term. This is my final answer. I want to show you one last example of a problem where it looks like it might be a perfect square trinomial, but it's not. So for this one, I'm going to write 4x squared plus 13x plus 9. And now this looks like the basic structure of a perfect square trinomial, because this 4x squared is simply just 2x times 2x, right? 2x squared. This 9 is 3 squared, so far it's looking good. But if you notice, the middle term, 13x, it's not 2 times 2x times 3. Right? This right here is 12x. What this tells me is that this is not a perfect square trinomial. And so the way you're going to have to do this is by doing the Xbox method. So I'm just going to put the answer here at the end. If you were to factor this using the Xbox method, you'd end up with 4x plus 9 times x plus 1. I would recommend you work this out on your own and make sure you're able to get this as your final answer. So again, just be very careful, because originally this problem almost looks like a perfect square trinomial. Right? The first term, 4x squared, you can write it as something squared. The 9, you can write it as something squared. But if you notice, you can't write this middle term, 13x, as 2 times the first term times the second term. And because of that, this is not a perfect square trinomial. So guys, watch out for that structure, okay? Make sure you be very careful. I hope this makes sense. If you guys have any questions, please let me know. I hope you guys have a wonderful rest of your day.